Hello from day 2 of Embedded World. I'm here with Alessandro Maggioni, Senior Regional Marketing Manager EMEA of onsemi. Today we're going to be talking about autonomous mobile robots. So, Alessandro, could you start by giving us a brief introduction to yourself?
Sure. My name is Alessandro Maggioni. I'm based in Munich, so I'm responsible for EMEA for the analog mixed signal group for onsemi. And I'm here today for talking about robots with you.
Okay, and also, what about onsemi? What can you tell us about that?
Sure. onsemi, we have our headquarters in Scotland, in US, so we are a global company about semiconductor, more than 30,000 people, employees, with different design teams and design centers all around the world, in all the continents and all the regions. And also we have in-house fabs, so we have all the full capability to support our customers on that way. So we are more than $8 billion revenue last year, so we are quite good and high ranking position with the company for semiconductor.
Oh, excellent. And now, can you start by telling us about AMRs? What are the primary industries adopting them, and for what applications?
Sure. So AMR stands for Autonomous Mobile Robot, first of all. So they are primarily using for all the kind of environments in which they have to move autonomously into the environment. So it can be used in different applications, different environment industries. Can be used for like cobots, can be used in pharma, in industry, so in factories to move things from one to the other. Can be, for example, for high-end consumer like lawn mowers and all those kind of activities which have to interact autonomous with the people in the whole environments.
Oh, excellent. And what are some of the challenges engineers are facing when designing AMRs?
The main challenge you can see as a designing is, of course, is the subsystem. So you need to understand where the robots is in the environment and which are the primary uses. So you have to divide by subsystem. So the main subsystem, of course, is battery keeped. All of them have to be battery keeped. So you need to perform and to design a proper way to have the proper capability in terms of battery, to have the right length. The other challenge is to have the interaction around the environment. So the robot have to know where it is and to be sure that it's not hurting any people around. So those are the main challenges, and understanding which are the main blocks you need to have for the proper design.
Okay, tell us about onsemi's AMR concept. I understand that you have a whole host of solutions. How are these designed to help engineers?
Yes, so we have this demonstrator. So we are creating these demonstrators as a sort of basis to help engineers to build up a basis for autonomous mobile robots. So the idea from us is to use our standard blocks, standard demo boards, to build up all the building blocks in the subsystem which are needed for the design, at least the basis of autonomous mobile robot, and that can be expanded with a different subsystem. So battery control, power supplies, sensing, image sensing, and so on.
Okay, excellent.
The idea is to help the engineers to have a sort of basis from which they can start to build up a solution.
Okay, and what about the BLDC motor control solution? Let's start with this. You have 2 platforms for this?
Yes, sir. So we can offer today 2 platforms. So one is based on Xilinx, which is using standard discrete gate driver and SiC. So these are used for when you need more power computation, so more algorithms capability or more power. So then also we have another solution based on our LCD 83591, which is a 3-phase BLDC for low voltage, 60 volt. So this is used, for example, where a low power is needed, or to drive, for example, the wheel. We have a proper and compact solution for even for compact application.
Okay, and what about autonomous robots that have movable arms? This must require some accurate positioning feedback.
Absolutely. So this is one of the important things, because when you are moving an arm into an environment, so you have to be sure that the main control knows exactly where the position of the arm is. So you need a sensor or an encoder which is calculating exactly the position is to be sure that it's not hurting anyone, especially because those equipment, those robots are in an environment with person. And also it's important to have absolute encoder, so which in any case when the power is down, so you know exactly and the startup where the position is, avoiding any involuntary movements to to go into position. So this is why we have for our solution using our dual inductive sensing board, so NCS 32100, which is have the same accuracy of quite complex and high cost optical encoder, but with a much low cost and the same position.
Okay, excellent. You mentioned a bit of sensors. Can you explain the importance of sensor selection and placement, ensuring the navigational efficiency and safety of AMRs?
Sure. So as we discussed before, so the AMR are objects which are moving independently into the environment. So they have to know exactly where they are, and also they have to know what is around. So the position of the sensing is really important to understand, to avoid to go against a wall or an object, or to go to, which is most important, also to hurt any person. So having all the sensing around in the right position, for example, to avoid to go to against object, for example, ultrasonic sensing is also important. Camera image sensing are important also because you need to recognize where you have to go with some intelligence behind, also where you have to go back home, let's say, and also all the application around to avoid any problems of the robot. I mean, because they are really conscious where they are inside their environment.
Yeah. Okay. Well, now looking at the power supply solutions you offer for autonomous robots, what can you tell us about this?
Sure. So the main or the common subsystem of all the AMR is that battery equipment. So of course the kind of the battery and the kind of the power needed is depends on the application you need. Can be a small robot with a very small battery that can be replaced every time he's moving, or there is a bigger robots which have to move and they can be charged only at the end of the day or the third shift, or can be charged on the way, for example, for some stationary. Here is important to define and design properly the power supplies, so what is on the board and for the battery equipment to drive the payload, and also to charge the batteries. So we as onsemi, we can provide a high performance solution for what regarding the charging. So using our technology, our top technology in terms of AC/DC, so power factor corrector, for example, using our SCP-1681, which is the only one on the market as analog PFC, bridgeless totem pole, so providing very high efficiency, plus all the solution with LLC, quasi-resonant, all the solutions are needed to provide a really high performance AC/DC power supplies. For what regarding on board, also you need, since those devices, those applications are battery equipment, so you need to transform from the battery power to all the application you need it, for example, to drive the motors, to drive an armor robot on top, or whatever is needed. So in this case, we are providing our board for the FAN 65004, which is the integrated 65 volt DC-DC converter, capable with up to 6 or 8 amps, to provide the full power is needed for battery level down to the lower level.
Oh, fantastic. I understand your autonomous robot concept is equipped with LED lights.
Yes.
To show its presence to people and other robots. What can you tell us about this?
Again, the robot has to move around the person. So it's important that on top of see where it is and detect obstacle, is also important to assign or provide information to the person around. So this is important that a proper lighting communication is in place. So for example, you need to understand when the robot has a battery which is uncharged, or there's some fault, or is stuck somewhere. So a proper LED driver which provided the proper signal or with visual communication is important. So in this platform, we're using our NCV7685, which is an automotive taillight driver. So it's composed by 12 channels, up to 60 milliamp individual PWM. So in this way, we can drive different patterns of string of LEDs in order that we can generate a proper pattern of light to basically to provide the right information based on some, of course, some pattern to the end user to understand what happens to the robot.
Okay, and finally, there are a number of building blocks in the module which can be connected with a single pair Ethernet connection. Can you expand on this?
Sure. Again, the concept or EMR are built with different blocks. So all those blocks have to communicate each other. So you need to understand when you need to charge the battery, you need to provide information to the wheel, to moving on. So here the solution we provide as onsemi is using a 10BASE-T1S single pair Ethernet, so which is Ethernet based, so 10 megabits with our NCN 26010, so which is a MAC-PHY transceiver for 10BASE-T1S. So the advantage here is you're using a very small twisted pair cable to provide up to 10 megabits solution with a standard Ethernet, so is a IEEE 802.3 CG standard, so fully compliant, and is also to help to simplify the connection, because it's already Ethernet based, the connection with all the building blocks to a central gateway.
Okay, excellent. And talking about AMR design, what trends are you seeing in the future, and what new features might we expect to see?
This is a good question. Well, first of all, the future is very wide, and every day we see more and more trend, more different application. What we see for sure is that EMR have to become more efficient, because also due to the fact that they need to save energy. So you need to stand longer with the same battery. So one of the real trend is to have more efficient solutions on board, communication, interaction with the environment. So more powerful CPU, more powerful image sensing, and adding more and more function, especially of staying to the environment. So how they can interact with external world.
Okay, and lastly, how is your partnership with DigiKey helping you deliver your solutions to your customers?
So you can visit the DigiKey web pages, in which you have all the information. If you need more information about our solution, so you can go on www.digikey.com. So because you have our EMR cooperation with you, so you can see all the information, you can download all the information there from your web page.
Excellent. Alessandro, thank you very much for your time. Enjoy the rest of the show.
Thanks a lot.